Welcome to Geography 02. Today, we will be studying various concepts related to drainage systems, landforms, and geological agents. First, let's address the streams that do not follow regional slopes and drain across geological structures. These are called in-sequence streams. This was a question from a 2021 exam. The genetic classification of drainage systems is based on origin and relation to rock structure and slope. Concordant drainage streams agree with the slope and geology and include consequent, subsequent, resequent, and obsequent streams. Discordant, or insequent drainage rivers do not follow the land's slope or rock pattern. They include antecedent drainage, like the Indus and Brahmaputra, and superimposed drainage, such as the Damodar and Subarnarekha rivers. The correct match for landforms and agents is option B. Barchans are aeolian, meanders are fluvial, saddles are glacial, and stacks are coastal. This image shows an example of discordant drainage. A river is cutting through an uplifted ridge, maintaining its path despite tectonic uplift and forming a sharp V-shaped notch. Here is an example of aeolian landforms, specifically coastal sand dunes or Barcan dunes, formed by wind or aeolian forces near the coast. These dynamic formations exhibit distinct slip faces and crests. This aerial view illustrates fluvial landforms, specifically river meanders. The silt-laden river carves intricate curves through the dense jungle, showing distinct point bars and cutbanks. A sea stack is a coastal landform. It is a large, vertical column of rock formed by the processes of coastal geomorphic change, primarily erosion. To summarize the differences, alluvial is river-made sediment, facies are environment-based sediment features, glacial is ice-made debris, and coastal formations are shaped by waves and tides. For the next matching question, the correct answer is C. Faulting corresponds to escarpment, 3. Wave erosion to stacks, 4. Ice scouring to kettle hole, 2. And wind erosion to yardangs, 1. Here are the landforms and their geomorphic agents. Faulting creates escarpments. Wave erosion creates stacks. Ice scouring forms kettle holes. Wind erosion results in yardangs. This image shows an example of a fault escarpment. Observe the clear linear cliff face separating the upper plateau from the lower valley, consistent with a fault scarp. Kettle holes are depressions formed in glacial outwash when a hidden block of ice melts. The diagram illustrates this process from glacier and ice block to outwash plain with kettle holes. The most destructive earthquake waves at the epicenter are L waves, or love waves. These are surface waves that cause the most damage due to their high amplitude and horizontal shearing motion. Let's review the different types of earthquakes. Tectonic earthquakes, the most common, are caused by plate movement along fault lines. Volcanic earthquakes relate to magma movement. Collapse earthquakes occur when underground caves collapse. Explosion earthquakes result from chemical or nuclear blasts. Induced earthquakes are human-made. Earthquakes are also classified by depth. Shallow focus earthquakes, 0 to 70 kilometers deep, are the most common and destructive. Intermediate focus earthquakes range from 70 to 300 kilometers. Deep focus earthquakes, 300 to 700 kilometers deep, are rare and cause minimal surface damage. The shallower the focus, the more destructive the event. Seismic waves are divided into body waves, which travel through the interior, and surface waves, which travel along the crust. P waves are primary and fastest, traveling through all mediums with a push-pull motion. S waves are secondary, slower, travel through solids only, and move in a transverse, side-to-side motion. Surface waves are generated when body waves reach the surface, causing the majority of destruction. L waves, or love waves, cause horizontal, side-to-side shearing motion. R waves, or Rayleigh waves, cause a rolling elliptical motion, similar to ocean waves, resulting in severe shaking. In summary, body waves, P and S waves, travel internally, while surface waves, L and R waves, travel along the crust and are responsible for major damage. illustrating their distinct propagation paths and motion patterns.
For this matching question, the correct option is B. Loess corresponds to wind deposits, moraines to glacier deposits, and gravels to river deposits.
The image highlights that loess is wind-blown silt, moraines are rock deposits from glaciers, and gravels are fragmented rocks transported and deposited by river action. This image shows a glacier moving and carving the landscape, illustrating the formation of moraines and other glacial features as the glacier retreats. Thank you for joining this video. We hope this geography session has been helpful. We covered key concepts in drainage systems, landforms, and geological agents.